You know now what protons, neutrons, electrons, neutrinos, positrons, and photons are. To refresh your memory, you can always double left click on the name proton, for example, and a definition will come up. Right click on that text and it disappears. If you want to just have a summary of all these subatomic particles, double click, left click on DEF, and this beautiful table appears that summarizes everything what you know about protons, neutrons, neutrinos, electrons, positrons, and photons. Now we want to look at notation for the elements, and we have here hydrogen, hydrogen 1, hydrogen 2, helium 3, and helium 4. And by putting protons and neutrons in these square brackets, we indicate that they are in a nucleus. So here we have one proton in the nucleus, and this is the element hydrogen, and the raised number 1 before it indicates that it consists only of one proton and nothing else. And the plus behind the H indicates that it has a positive charge of +1. There's also an isotope of hydrogen that has only one proton, but it has also a neutron in its nucleus. So it has two subatomic particles in the nucleus. Therefore, we have a 2 before the H, but the charge is still +1 because the neutron has no charge. If we add now to this nucleus another proton, so that it is 2p plus and a neutron and 0, we have 3 subatomic particles in the nucleus, so they raise 3, and the element is now helium, because helium is an element that has 2 protons in its nucleus. And as it has 2 protons in its nucleus, the charge is 2 plus. There's also the main isotope of helium has 2 neutrons and 2 protons in the nucleus. So you add 2 plus 2, you raise a 4 and write He for helium. This is 2 plus, and this is called helium 4. Please remember that the name isotope of an element means that it has the same number of protons. So for helium, 2 protons, but it has different numbers of neutrons. And if helium has 1 neutron only, it is called helium 3, and if it has 2 neutrons, it is called helium 4, and the 4 means that it has 2 protons and 2 neutrons. Right-click now on this table and let us practice this a little bit. Here you see 1H plus. So what would you expect to see if I double left-click this? Well, you expect only to see 1 proton. What do you expect to see if I double-click, left-click 2H plus? one proton and one neutron. So two subatomic particles in the nucleus, but one of them is only a proton. Helium is a different element than hydrogen, and we know that helium has two protons, and the 3 means that it must have one neutron. So now let us see what would be for helium. That means it has 4 subatomic particles in its nucleus, and of course 2 have to be protons because it is helium, but it can have, now it has 2 neutrons. Practice this again by double left click, do it, and then you can pull over the information you need. We need for this P plus, and to indicate that it is a nucleus, we put a bracket around it. This obviously is a neutron and a proton, so we indicate it by putting a bracket around it. That means it is in the nucleus. And here we have 2 protons, so we put here 2, double click, 2, and 1 neutron, and we put again these square brackets around them to indicate that it is in the nucleus. And this is now very easy. We have 2 protons, we have 2 neutrons, and they are in the nucleus. Therefore, we put them in brackets. Now let us say the same thing. This is hydrogen. It is only a different way of representation, but it means all the same thing. So this is hydrogen. This hydrogen has only 1 subatomic particle in the nucleus, so it is hydrogen 1. Here, this hydrogen is also hydrogen because it has only 1 proton, and it has 2 subatomic particles, 1 proton and 1 neutron, so we call it hydrogen 2. Now this one is called helium because it has 2 protons. This one is also helium because it has 2 protons. This one has 3 subatomic particles, 2 protons and 1 neutron, so it is helium 3. And this here is helium 4 because it has 2 protons and 2 neutrons in its nucleus. Now we want to put the charges in, and so this is plus, and you don't need to write +1 because it's only plus. And here we have a positive charge of 2+, and that is the same for helium 4. Of course, you know, if we add an electron to a helium, it would become neutral and we would take the plus sign away. Now we have the vocabulary to describe how the sun generates energy. Double left click on equation for nucleosynthesis of hydrogen 1 into helium 4, and this equation comes up. What you need is 4 hydrogen 1 plus 2 electrons, and that gives you 1 helium-4 plus 2 neutrinos plus 6 photons, and it releases energy in the form of neutrinos and photons, which is Q equals minus 26 mega electron volt, MeV. We can illustrate this very easily now by double-clicking hydrogen, and you see here we get hydrogen 1. We need to do that 4 times to get the, and we keep them apart to make very clear that this is, they are not together in a nucleus, these 4 protons. Now we have to add 2 electrons, and we double left click on E minus down here, and we got 1 electron, and we get another electron. And these together, these 4 protons and 2 electrons, will fuse into a helium-4 atom or nucleus. So this is, and we put them together to indicate that they are in a nucleus. Now we have to add 2 neutrinos, and we have to add 6 photons. Right? 3, 4, 6 photons. These 6 photons is essentially the energy that is released during the sun's nucleosynthesis, nuclear fusion, and a little bit of energy is also released through the neutrinos. Let's see what I remember. Here I have my button Do It. I double left click, and I want to remember that what I needed was, I needed 4 H1 which has a positive charge of +1. So I take 4 of those. I need 2 electrons, and this results in 1 helium-4. That means it has 2 protons and 2 neutrons, and that has a positive charge of +2. In addition, I get 2 neutrinos, and I get 6 photons. And this releases energy which is incorporated in the neutrinos and the photons. So I think I did this correctly. If you could do that at home, this would be called cold fusion, but it would not work. This reaction, nuclear reaction, happens in the core of the sun, where the temperature is very, very high. Just to show that here we double left click on Sun, and this is essentially the conditions which you have. The temperature has to be 16 million degrees Kelvin, which is about the same as Celsius, and the pressure has to be 100 billion times. That means 100 billion times the pressure of what you have on Earth. And only under these extreme conditions, the nuclear fusion of hydrogen into helium occurs.